leakage is associated with increased energy bills. So the less air leakage we have, we can expect our heating bills to be lower. They're tied together. Another reason why we want low air tightness is that air leakage brings moisture with it in the air, and that can lead to decay of framing members, or it can lead to rot.
This becomes a very visual test, a test that allows us to share information readily in terms of areas that maybe weren't properly detailed or areas that might have been missed initially through the team. And it creates a learning potential, I think, for the guys to really, next time they're doing this, think about the results they saw here. And I think part of this is continual improvement, the process improvement that's part of building better homes.
There looks like a slice in the vapor barrier up here, just where someone missed some tape. We'll have to patch that up.
Generally speaking, we're looking at sort of the, from large to small, we're looking at sort of the major penetrations in the building enclosure. And those could be looking at windows and doors, which generally are the largest in terms of the complete straight through penetrations. And then any mechanical penetrations, any stacks, any plumbing fixtures that go straight through into the enclosure or through the enclosure. And then also things like external lighting, where we have switches on the outside or lights around entry doors. These areas where wiring is going through also tend to be key areas of potential infiltration or exfiltration of air.
So this is the electrical wiring that's going to go to the lamp fixture on the outside of the building. And of course the electrical wiring has to come into a plate here so we can turn the light on and off. Well, that's a relatively thick wire, and it's penetrating the house. It's actually going through the wall. In fact, this is a double wall house, which you may or may not know from previous videos. But so this is a hole that's going to go all the way through the wall. What does that do? Look how they've sealed it. So it goes all the way through. They've sealed it on the outside. They've sealed it on the inside. Not only that, they've caulked around where the air barrier is on this penetration, and then they've taped around.
A substantially airtight house, better than code or substantially better than code, could see 10 or 12% increases or enhancements.
So we are all set up to do a final air test for this house. We have the fan set up on the door to do a blower door test. That's going to measure the air leakage across the envelope of the house, meaning the exterior walls, in order to measure the air leakage across it. And then it's going to give us a final number in terms of ACH, or air changes per hour. The code allows you to have 3.0 ACH if you are testing, and then if you're not testing, it's an assumed 2.5. So we can kind of use those two numbers as like the max ACH that we want to try and target to be below. And so yeah, we're gonna see where we're at now. Today we're really doing it to see what the air tightness is, again, across the exterior envelope of the building. Why that matters is for homeowners, if we have a lot of air leakage, that translates to heating bills. So how much does it cost to heat the house if we're losing that warm air? Another reason that we would want it is just to make sure that we don't have failures in the building assembly. So if we've got a lot of air leakage, that could lead to water coming in, that could lead to degrading of wood members or to rotting. So we want to make sure that we don't have, on a production home standpoint, a lot of callbacks or any issues down the line for the person who's actually going to be occupying the home. And then we want low enough air tightness so that we can really make our mechanical systems be the ones that are taking care of the ventilation. So we just finished, and the final air tightness score was 1.82 ACH. And so, like I said before, when we are testing the houses, then the code wants us to be below 3.0 ACH.
Right.
So you're obviously well below that.
Right.
Your CFM 50 number went from being above 1,000 to being just below.
Right.
And I think it fluctuated when we did that previous test.
Right.
And there are still some things that aren't done, like all of the trim that isn't done
Right.
within the house. That'll cut it down a little bit more.
Right.
But really at 1.8 ACH, that's low enough that you're not worried about homeowner callbacks. We didn't find any really big holes. That's really the purpose.
Right.
You're not going to be worried about heating bills. It's going to be
Right.
comfortable to live
Right.
in this home. So you've
Right.
really met the requirements of the code, exceeded them, and then you've guaranteed whoever's going to be living in the home that they'll have a comfortable home to
Right,
live in.
right. Okay, well that's great. I mean, that's what we were aiming for. So.